Hi everyone, my name is Vinod and this is my second video of C9800-CL deployment on ESXi platform. In this video, we are going to see AP joining to C9800-CL. So in the previous video, we saw that how do we install C9800 in ESXi. We also saw that how can we get access to the GUI and how can we make sure that appropriate network adapters are mapped to the V switches, and how do we get those security features enabled in ESXi, which includes promiscuous mode, forge transmit, and MAC address changes. Now in this video we are going to have a demo on how can we get the AP joining to C9800. But before that, let me tell you some prerequisites, as well as we also need to understand a bit on how C9800 has been built from the software perspective, because we are not anymore running iOS as a monolithic software on hardware. So I'll make you that, I'll give you that clarity as well. So let's start. So the first one is about prerequisites. So before we start actual AP joining to C9800, we need to make sure that we got a self-signed certificate already there in C9800-CL. So we have already done that. We executed CLI command, which has been highlighted here, or which is, which we need to execute. If you are not, or you haven't done that, as a day zero web UI wizard, you would actually be asked to configure that, enter the password, SSH. You would be asked to give or fill the details like password, SHA, type and everything. So you would need that certificate to be installed on your C9800-CL. But that's not the case for hardware appliance, right? Because hardware appliance has got an inbuilt MIC, so you don't need SSC there. The second is your gig 2 should be configured as a trunk, because you're going to pass client traffic as well as the AP management traffic. The third one is about security settings, which I have already discussed in the part 1 of the first video of C9800. Yeah, but here I'm repeating because it's very important, and Cisco recommending to have these two features to be accepted or to enable as accept instead of keeping default as reject. All right, AP model. Again, we need to make sure that AP model is supported on C9800, because there are some old models which are not supported. So you need to definitely refer wireless compatibility metrics on Cisco website. So let's jump on another thing, which is your iOS XE. Now, as I was telling, it's not a monolithic era of iOS, how it used to be there on a hardware appliance directly. Because in a monolithic world, it used to be like if you have a single process issue running on the hardware appliance as iOS as a single system, you may have impact, or there is a downside, which is like you have impact directly on the appliance just because one single process has an impact. But it's not the case here in iOS T or iOS XE. I'll tell you that. But before that, even there is another downside, which is here upgrade. Because if you want to upgrade in iOS world, in a monolithic world, it's like you have to get the entire system rebooted, because you are upgrading. There might be some issue with one process, or Cisco has recommended to, because there is a bug, or we have an issue with existing CPU utilization, which probably may trigger for upgrade. So yeah, so that has some downsides. But in iOS X is just like a process, or just like a daemon, which is running on top of your bin OS. All right, so it's a daemon which is running on your Linux kernel, and that's why if you see now, it is no more coming as one single software. It has got a multiple packages, or it comes as a package. So iOS D is a So the difference between iOS and iOS XE, iOS is a monolithic software which runs on the hardware appliance directly. So the downside of having that kind of system is, if one of the process has any impact, it actually gives it impacts on entire system, right? the same thing goes with the like upgrade phase. Like you want to upgrade, you have to upgrade the entire system, you have to reboot the entire system. But it's not the case in iOS XE. iOS XE is like a package, or it's a service which runs on top of Bin OS, and it has, this process has all like including command line, routing, multicast operations. So it's a daemon which is running on the Bin OS, and there are different daemons. In Linux terminology, it's daemon because it's running as services. You have got multiple daemons in C9800, which includes your wireless network control daemon, RRM daemon, rogue daemon. So basically, you're not relying on everything sitting on one single hardware. Or it's like you have got a different processes. So that is where the advantage is. You're actually splitting that daemons into different CPU for a processing. That way you can balance the processing, and you will have a better performance compared to your traditional iOS. So you need to keep this in mind when you're actually trying to understand how AP joins, which daemon actually matters when AP joins. What Cisco does is, in this particular daemon, or this particular process has got access point and client sessions, so which includes your CapWeb discovery, AP joining, client sessions, and whatnot. So this is very important. And if you see now any Cisco document, Cisco always recommend to have a horizontal scaling when it comes to WNCD. And that's when Cisco recommends you need to have site tags configured. You need to have AP join to join across different WNCD processes just for horizontal scaling. And you should not rely on the default site tag. You have to have manual site tag created. That way you can balance the processes and your AP at the same site. So that's very important when you're actually considering AP joining. And the another thing, other than your iOS XE structure or iOS XE how it comes in C9800, another important thing is your tracing and logging. So basically, it's a binary tracing idea, right? Every process, while it is running, it also writes the logs. So you need not to execute any command to enable logs. It automatically enables, it automatically writes the log into respective memory. So this is like added advantage having binary tracing enabled, binary tracing by default writing the logs. So this is another important thing, which is about tracing and debugging. So in C9800, binary tracing idea is all about Linux processes while they are running. It always writes the logs. So that's why it's called always on tracing. So you need not to enable particular command to get the logs. It will be already enabled by default because it's because it has a default. So iOS XE tracing. So iOS XE tracing and debugging. So this is something we need to keep in our mind while making AP join or client gets connected, because it's very important. It's not a way of how we used to troubleshoot in the AirOS controllers. It's not the same method we are following here. Logging session stored into the respective memory. That's why it's called always on tracing. All right. And these are the commands from the wireless perspective. If you give this command and execute for that particular MAC address, you will be able to see what logs are been stored for that particular AP join process, or let's say client is getting connected. So you can have that details. Another thing is trace on failure. So there might be a scenario where you don't know exactly, or you want to overall see the performance and the kind of issue summary, whether it is AAA authentication issues, or there are some issues with the AP join, there are some issues with the client association. So you can get operation wise count based on trace on failure output. So this is another thing which is very useful when you are trying to troubleshoot a particular issue. Radioactive tracing. So radioactive tracing is a conditional debugging, or it's a debugging which in our AirOS we used to execute multiple debug command. Here it is not required to enable multiple debug commands. You just have a single command, irrespective whether it is for access point or client. Just need to enter the MAC address or the IP address of that particular session, whether it is client or access point. So debug wireless MAC or debug wireless IP. IP is like IP address of access point or client. All right, and then other than tracing, you have embedded packet capture feature in C9800. So the packet which enters into the controller and leaves from the controller is been captured with the help of this feature. So you need to enable this feature. It's you need to execute these commands and enable it, and then you will actually get a PCAP file which can be downloaded from BinOS folder and open into the Wireshark. So it's very important when you are trying to troubleshoot AP joining. All right, I hope you got these details now. Let's start with the demo now. Right, let me log into the controller and show you if I got any access point here. Show AP uptime. There's no AP, and this is my current version 17.6.1. and if I see now my current time, it looks okay. So if you see now, this is my Ntp server. I have actually configured a Ntp server. Ntp status, you see here, this is my Ntp server, which is my Active Directory, and clock is synchronized. So it looks good from the time perspective, because this is very important when we are trying to register access point, because we need to trace back the logs. In that case, the time should be we should able to track the time, right? So if you see here, before starting AP join, we need to see, clock is fine, and I can execute show logging. So I have already gone through all these always on tracing or IOST loggings or radioactive tracing. So now this is your show logging, which actually gives you general information of the box from the iOS perspective. So if you see here, my interface is when it came up, and then I got NTP configuration done, NTP is reachable. So all those general logs you would get, but from the wireless perspective, you see here, I don't see anything related to radio or anything related to access point. All right, so that's the way the logging works here. So I would be executing all these commands. I have already executed show AP uptime, and I have shown you there is no access point. And show wireless states trace on failure is overall it shows whether you're like you have got 500 access points on setup or number of access points. You can see overall summary of how many access points failed, or from the client perspective, it will be like a snapshot of getting details in terms of what is gone wrong or is everything looking good. All right, so that's a trace on failure. And then you have got a radioactive tracing. So now I'm going to enable debug wireless for access point joining, because that will actually show us the step-by-step process which AP would follow in terms of discovery request, response, join request, and join response, and how the DTL is, the tunnel gets formed. So I'll enable that, but before that I need to see the MAC address. So let me show you my access point, and then probably we can jump on preparing debugging and start even initiating the embedded packet capture. So I have got commands to, probably we can start on the debugging. All right, so as you can see now, AP is showing as not joined. Let me just confirm again so that we can initiate troubleshooting. So it's showing it is not joined. Show AP tag summary is showing nothing because there's no AP. So what I'll do is now, instead of running always on tracing or any other command show logging, we will straight away go ahead and start debugging, and embedded packet capture will actually enable in the controller. All right, so let me enable debug for this controller, for this access point. Debug wireless Mac. All right, and debug wireless IP in case of AP registration. Debug wireless IP 192.168.30.11. If I see now whether the debugging is enabled, just to confirm that, it shows conditional debug global state start, and it is enabled for IP and MAC address. So debug is done. Now let me run packet capture as well, so that we will get packet capture also, and then we'll walk through the packet pcap file. All right, so let me enable that. So what I'll do is I'll enable only for the IP address which is for the AP. So I'll enable with the access list. So I've given access list name as Wi-Fi 256. By the way, that's my channel name. And then only for the IP which is specific to an access point, I'm enabling this packet capture. So the access list is created. Now let me go back, monitor capture AP cap. AP cap is my file name. Clear, there is no packet capture. So just to get the confirmation, interface gig2 on both, then monitor capture AP cap, buffer size, let me keep as 200. All right, 200. Okay, so the maximum size is 100 MB, so I'll keep 100 MB. Then monitor capture AP cap match any. And monitor capture AP cap access list, and my access list name is Wi-Fi 6. So Wi-Fi 256. Yes. All right. And now I'll actually start packet capture. So packet capture is started, debug is also started, and as you can see there in the access point LED state, it's showing LED green is blinking, and it's actually alternating with the red color. So that means it is trying to discover or it is trying to connect to the network. So let me connect, or let me enable that port. All right. So I'm enabling the upstream switch port. So just ignore about this Meraki as of now, because I have got upstream infra as Meraki, but otherwise just think as your upstream switch with the PoE feature enabled. So I'm enabling that port. It's a PoE capable switch, and I have configured VLAN 30, and that's it. So once I enable, AP will get a required power, and it will try to acquire the IP address. So I have already started debug. So let me connect my access point to the upstream device. So let's see, once we get that, I will also try to get the, okay, let's wait for that now. But in meantime, let me just confirm if everything looks fine. So I will also check the Dhcp scope configuration. I had configured IP pool AP the earlier release was there, so it will get the same IP address, scope. Okay, so I had configured on one controller with 192.168.40.140, but now our controller, if you see here, it is 141. So as you can see here, my controller IP address is 141. So let me go back to option 43 and configure 141, which is hexadecimal as 8D. Alright, so I have configured it. I'll probably refresh address leases and we are good now. Let's wait for some time. Hopefully it will get output for both debug and packet capture, and also we should able to see AP joining successfully. Since we have option 43 configured, gateway is there, AP should have IP address, so should be looking fine. So here in controller we can see now access point has joined. All right, now if I go back packet capture, the packet capture which I initiated, it's got saved here. You can export from here, and that is what I did. And this is the file name AP cap. If you see here, file name, let me show you. So this is AP cap file which got downloaded. I have exported. And now let's compare these both files, your debug output and your CLI output. Yeah. So you can see here we could capture all control packet, which is cap web control with 5246 as your UDP port. Once you get the control discovery request from access point, the response goes back from controller, and after that you have a server and client negotiation in terms of certificate handshake, right? So client as an AP try to say hello in DTLS, and then you get a certificate handshake from the server, which is your controller. So the certificate which I'm talking about is SSC. That certificate handshake happens, AP validates that certificate, and once the validation is completed, as you can see, afterward all the traffic is actually got encrypted. So certification validation done, the tunnel is established, and then if you see here, you can get all traffic as encrypted application data. So from the packet capture point of view, we can see the handshake from client and server, which is client as an access point and controller as a server, and I think you get a much more good clarity about how DTLS tunnel is formed from access point to controller, right? Now if I go back to debug output, so the debug output will be saved into the boot flash, starting the file name with RA_trace. So I got two different files. One file is been saved around 2 o'clock, right? And this is my recent one. That's why I was telling, we need to see the clock output as well, so that we know exactly our tracing is the latest one and we are able to get the right file to analyze. So I have got the radio tracing logs or debugging output, one for MAC, one for IP. So you see here RA_trace_IP, which is my access point debug output from debug wireless IP output, and this is my debug wireless MAC output. So let me open one file. So more boot flash, and let's open the MAC one, right? So you see here I'm able to, if I want to really see the output, or I want to really highlight what exactly I need to look here, One is your WNCD process, right? So this is one daemon which I was talking in earlier theory section in this video, that you have got a multiple WNCD process. So let me probably try to show you the WNCD process, right? Show process platform including WNCD. So you see here my controller, which is medium deployment type. I have got three WNCD process. So all the default tag or site tag would actually, I mean, let's say if you don't configure anything in, you don't configure site tags and you're relying on the default tag, then all APs would get registered into the default site tag, which is going to get into WNCDs_0. All right, so that is what I was telling earlier. So what I was telling is we got 3 WNCD process in 9800-CL, which I have installed. So mine is a medium deployment type. That's why I'm getting 3. If you deploy small one, then it is 1. So accordingly, 9840 might have, if I'm not wrong, I think it has got 5 to 6 WNCD daemons, different daemons, and then 9880 has got 8. So for example, let's take an example. You got a default site tag and you bring 400 access points, and those access points are getting registered to that default site tag, right? Because you don't have site tags configured. What happens as a default behavior is all those 400 access points will be load balanced across these 3 different WNCD process as a round in a round robin fashion. So what will happen? Your very next AP or your neighbor AP might be registered with WNCD 1, and you are registered to WNCD 0, for example, the AP which is part of WNCD 0. In that case, it's like a inter-process roaming, right? So it's not an optimal solution. That's why Cisco insists to configure custom site tag, and that would actually give you like within that site tag. Let's say you create a site tag which would be associated to WNCD 1, and then all APs would actually get registered to that particular WNCD process. So there's a load balancing mechanism in that as well, but it would make sure that, I mean, you need to design in such a way that, let's say you have a building wise site tags, you would create for one building one site tag, for another building another site tag. So the entire building would be part of one WNCD process, and that will be like an intra-process roaming, which is the optimal solution. And now coming back to debug output, debug wireless MAC output, you see here everything comes under WNCD 0, right? So my AP, since it is getting registered to default site tag, because I don't have site tag, it goes to WNCD 0. Now this is something I will check, and other than that I will see whether DTLS tunnel is actually having a proper handshake in the debug output as well. There is a complete, I mean, if you see here, as a part of DTLS session, there is a certification verification completed. That means my certificate is working fine, and my AP is able to get authenticated with that certificate, which is my self-signed certificate. And then my CapWap tunnel has been established as well. As you can see here, my join request is coming received from access point. So likewise, let me go back and open that same file, right? So you see here, this is my MAC output, join request is there, and then I got my AP registered, join response is generated, and my join processing is completed. and AP gets into joined state. So that way my AP has successfully joined. Another thing which probably I would check, for example, if your APs are moving from one C9800 to another C9800, it will try to validate those tags which you have configured into the, say, old 9800 controller where the AP was registered, and you're moving to different C9800. It will try to see that, and if it doesn't match, then it will actually move that AP into the default tags. Okay, so let me see that particular verification which has been done as a part of registration. So I was searching. So you're seeing here as error, right? Because it's telling that AP join RF tag validation is failed. That means I had this AP joined to another controller where I had a different site tag or RF tag configured, but now since that tag is not been there in this new controller, it is showing that validation is failed. And then if you see here, it comes as my default site tag, my default policy tag, and my default RF tag. And that's how you need to make sure that everything has been validated properly. Now let's say you want to move APs with the same site tag which were there in the existing controller. There are different options available. One option which I could probably configure is you want to push that site tags to AP flash, and there is a command to push that site or that tags into the AP flash. Once you execute that command, AP will have that in the flash, and then you configure the same thing in the new controller. AP will try to register accordingly and validate that. So that is something you can do it. Now another output which we want to verify is your debug for wireless IP, right? So let me go back with getting that file name, debug, more, and this one. Let me go back, right? So you might have got a question that why I am debugging IP and MAC address, right? So what's the difference? Cisco recommends when you are actually trying to debug AP join negotiation or AP join troubleshooting, you need to debug both, because if you, let's say, debug with the MAC address, you will miss the DTLS tunnel establishment, because at this stage a DTLS tunnel is actually built on IP address, and WLC has no idea about the AP MAC, and that's why you need to have IP address debug as well. So if you debug the wireless with the IP address, you might miss some debug output of radio related information like RRM related stuff. So that's why you need to get both the information, and for that you need to have debug output from both the commands, and that's it. So as you can see now, AP had joined to my default tags. Show AP uptime. It's been a long time, like 53 minutes. My AP is up now, so everything looks fine. I don't have any SSID configured right now. Nothing is there. So in next section we will actually go through the configuration model. Don't worry, it is not very complicated, it's not very difficult to understand. We will understand the configuration model in a simple way, so that it will be very easy to configure. For example, there might be some confusion for people, like if I have AP groups configured in AirOS controller, how can I move those AP groups into the iOS XE controller? So we'll walk through that. That will be in the next section. I'll do that. We'll configure one SSID and try to broadcast and try to connect the client, and also will debug client in that case. All right, so this is all about AP registration. I hope you're good with the AP joining process now. You can troubleshoot because you know exactly now when to execute radio tracing information, always on tracing, or trace on failure summary details, right? Thank you so much.